Okay, question 3. This is about a arithmetic sequence. So that's the first three terms, 5, 12, 19. So I think we just write down 5, 12, 19. You can clearly see that u of 1 is 5 and d is 7. So we want to find u of 10, which is u1 plus n minus 1 times by d. Okay, so that shouldn't be too bad. 5 plus 63 equals 68. B, prove that 3, 2, 1 is not a term of the sequence. So this is quite interesting, that the idea is that when we use the formula u of n is u1 plus n minus 1d, when we consider the n can only be integer values. So we substitute integer values for n, the first, the second, the third, the fourth, the fifth, and that produces our sequence. So all we have to do is show that actually there is no integer value of n which will get us to 3, 2, 1. So you can actually just find out, you can do this in a variety of ways. I'm just going to substitute, okay then. So if we have 3, 2, 1 as the number in the sequence, we should be able to get there somehow, if it is in the sequence, by going u1, 5, plus n minus 1 times by d. And when we do this, we get 316 equals, 316 over 7 equals n minus 1. But then we see that n minus 1 equals, and we just switch to our calculator. Let's just put it on Scratchpad here, that's fine. We've got 316 divided by 7. We do control equals, and we get 45.14. So n equals 46.14. Therefore, 3, 2, 1 not in the sequence, because n is not an integer. It's a bit of a fancy way of writing at the end there. C, find the first term of the sequence which is greater than 400. Okay, let me just put an extra page in here. Okay, so we've got u1 plus n minus 1d. This would be the term, and we want it to be greater than 400. Greater than 400. So u1 is 5 plus n minus 1 times by 7. I want that to be greater than 400. Now, because this is just a linear inequality to solve, it's probably not worth going to the calculator for this. But I want to show you this in both ways, because when it's a sum, the summation turns into a quadratic, and it might be worth switching to a calculator technique. So let's do both ways, and you can compare and contrast each time. So if we count the algebra one, this is just 5 plus 7n minus 7 greater than 400. 7n minus 2 greater than 400, 7n greater than 402, therefore n greater than 402 over 7. Calculator, 402 divided by 7, control equals, n greater than 57.4, therefore n's got to be equal to 58. Notice it's not n equals 57, the closest integer. It's got to be greater than 57.4. So we have to have n equals 58. Now I'm going to just go back here. I'm going to go to a graphing page. And in here I'm going to graph this left-hand side here. I'm just going to graph all of this. I'm not even going to expand it. I'm just going to leave it like that. So 5 plus in brackets. Now this is going to be n changed into x when we put a function. X minus 1, close bracket, and then times by 7, we enter it. Now it doesn't matter so much the visual on the screen here, because we're going to go Control T, and my table of values, can you see x, these are the n values, and so we already have a nice little output generator. So when n is 21, 22, u of 23, u of 22 is here. So all we have to do is just keep going up until we actually surpass 400, and can you see it is there? Okay. So what I would do here is maybe, get my pen back on, from GDC when n equals 57, u57 equals 397. And when n equals 58, u of 58 equals to 404. Therefore, n equals 58. And maybe you don't actually even need to put this or this, because can you see you've actually already got the n here and here. So I think all you have to write down is this, and then this. Okay, so you compare the two methods here on the left-hand side, just going with the algebra method. Some of you like algebra and thus solving equations. And the right-hand side, just using the power of the GDC and the table of values. Both have got merit. Maybe on this occasion, the left-hand side is quicker. But in future situations, maybe the right-hand side will be quicker and maybe more accurate, less prone to make mistakes.